Dear learners, welcome to the channel again. Today's topic is homogeneity of variance. Homogeneity of variance refers to the assumption in statistics that the variance of the residual, which are the differences between observed and predicted values, is constant across all the levels of independent variable. In similar terms, it means that the spread of the data points around the regression line or mean remains roughly the same across the entire range of the predictor variable. Here are few examples. Example 1. A scatter plot. Consider a scatter plot where you are analyzing the relationship between the number of study hours per week and exam scores for a group of students. Homogeneity of variance would imply that the spread of the exam scores around the regression line remains consistent across all the levels of the study hours. In other words, we can say regardless of how many hours a student studies, the variability in their exam scores should be approx the same. Example 2 is there. In ANOVA, homogeneity of variance is a critical assumption. Suppose you are comparing the effectiveness of 3 different teaching methods ABC on exam performance. Homogeneity of variance would mean that the variability in exam scores is consistent across all 3 teaching methods. If the variance of scores differs significantly between groups, it violates the assumption of homogeneity of variance, and the results of the ANOVA may be unreliable. There is one more example to understand this concept. Example 3. Levin's test is a statistical test used to assess homogeneity of variance. Suppose you are conducting a study to compare the anxiety level of the participants exposed to different therapy methods. Group 1, cognitive behavioral therapy, CBT is also called for this. Group 2, mindfulness therapy, and third one is supportive therapy. Before conducting an ANOVA, you perform Levin's test to check if the variances of anxiety scores are approximately equal across the 3 therapy groups. If this test indicates a significant difference in variances, it suggests that the assumption of the homogeneity of variance may be violated, and you may need to use alternative statistical method. So, in conclusion, we can say homogeneity of variance is an important assumption in many statistical analysis. Violations of this assumption can lead to biased estimates and incorrect conclusions. So it is essential to assess and confirm homogeneity of variance before interpreting the results of the statistical tests. Thank you so much.